Hi everyone, I'm Giusy Portolan from Deep Blue. I'm a human factors consultant, and today I'm going to talk about the ASTAIR project, which is focused on automated airport ground operations. ASTAIR is an exploratory research project at IRL1, funded by CESAR under the flagship of Connected and Automated ATM. The project started in 2023 and it's now coming to the very end in February 2026 and has seen the work of different partners, ENAC, Group Aéroport de Paris, to Delft, Eurocontrol and Deep Blue. So the focus of ASTAIR, as I said, is on improving ground operations at congested airports. For example, in major hubs such as Paris-Charles de Gaulle, Amsterdam Schiphol, Fraport, which see a lot of arrivals and departures every day. The focus starts from a problem statement. Departure delays in Europe have increased. For example, in 2023, the average departure delay per flight was almost 18 minutes, with reactionary delays adding up and creating a snowball effect that could disrupt the operational day. And this comes also from one of the factors is the efficiency of ground operation, especially taxi speeds that are manually decided by the pilots based on different variables such as the weather, the complexity of the airport, and therefore it shows a critical need to improve the efficiency of ground operations in this type of airports. So ASTAIR is expected to improve the capacity, the predictability, the environmental impact and the safety of ground operations. How? By using an AI system support tool that automatizes the supervision of ground operations by doing two main things. The first one is pre-calculating conflict-free trajectories for aircraft and tags 20 minutes ahead of time. And the second is sending creating the speed profile based on the conflict-free trajectories for each aircraft and tags and sending them directly to the aircraft via data link instead of radio communication to avoid communication errors, human workload. In this case, the ground controllers, the ATCOs, will become more like a high-level supervisor intervening only in case of emergencies. The concept was validated through a series of workshops with different stakeholders and operators. Indeed, we discussed about which are the difficulties of these airports. We discussed about which are the roles that are going to be impacted and why by the solution. In our case, mainly the pilots and ground controllers. And we discussed also about which level of automation the concept needed to be functional and which use case to be covered, both nominal and not nominal. Based on this, two HMIs were created of this tool. The first one is this one, developed by ENAC and used during the real-time simulations. As you can see, there is the global traffic supervision, which is a radar image in which you can see all the traffic of the airport. And on the left, there is the columns. At the very left, there is the column with all the traffic to be integrated, in blue the departures and in red arrivals, and three different columns based on the level of automation. The first one is the AI. So if the aircraft is on the first column, it means that it's being managed by the AI, by pre-calculating the free trajectory and so on. The second column is the human-AI collaboration. So it means the aircraft needs an action from the human controller. And if the ground controller thinks that an action should be taken, the aircraft can be moved to the fourth column, so under the human control. And on the right, there was also an inspection interface, which shows on a different screen the future of each aircraft. So the controller could check what the AI was doing and which conflict-free trajectories was calculating for each aircraft. The second HMI was developed by TU Delft for the fast time simulations, and it used a multi-agent motion planning algorithm, so a higher level of automation, and it was only just one screen with a radar image with the inspection interface overlay. On the left column, there was all the flights controlled by the AI, and on the right column, there was the issue commands. So the messages will appear when the actions need to be taken. For example, maybe an aircraft that needs to go back to the parking stand because it had a technical failure. And the ground controller could choose the action with the related details and send it to the AI to let the MAS execute them. So the validation of ASTAIR was done by workshops with the stakeholders and the operators. In our case, the stakeholders and operators involved were air traffic controllers, airport managers, pilot representatives, ground operators, and apron operators. And we also use the real-time simulations and fast-time simulations, the liability tool to understand if there were any liability risks within the concept, and different questionnaires to understand the operator's experience, such as usability, situational awareness, engagement, and cognitive workload. So the validation objectives were the operational feasibility of the concept for the operators, the assessment of the human-machine collaboration, the usability of the HMI, the effectiveness of the planning algorithm, and the legal liability. So, since we are here for the topic of operators' experience, I focused on the human performance-related results of the solution. So the system effectively supported the teamwork and integrated well into the workflows of operators. Indeed, the participants showed a good cognitive workload. It remained manageable throughout the runs of the simulations, and furthermore, it decreases with the familiarity of the tool. And participants also showed a high trust in the AI system to manage the traffic, especially for routine tasks, letting them to focus on the emergency situations. They also had a high level of engagement with the tools, especially during real-time simulations, but they noticed a shift in the role from active controller to more like a supervisor, a passive role, and they noted that maybe this could impact on the long term on the job satisfaction. Furthermore, the system was quickly understood with minimal training. Indeed, the usability was assessed, and the score was 62.5, which means marginally acceptable. For the maturity of the project is okay. There were a lot of different areas to be improved and have been identified. For example, the fact that the inspection interface was another screen, and they said maybe to be integrated in the main screen to avoid visual attention spread. And but overall, the participants showed a good situational awareness of the traffic. Indeed, we used the Saga technique, so every now and then we stopped the simulation to ask the participants about the traffic, and they answered correctly 80% of the time. So overall, the tools were well received by all participants. We also used the liability tool, and we understood that the key problem from the point of view of liability is the authority of the AI. So if the AI fails, who is responsible? The answer is that for a project at this TRL is that the human controller still needs to be in control of everything. So even if the AI makes the plans, the human controller still needs to check everything. Another limitation of the study was that we missed the pilots in the loop of the real-time simulations, so we had them only pilot representatives during the final workshop for validating the results, so for further research, maybe also the pilots could be involved. Thank you.